Okay, so the hypothesis test for the golf clubs. What assumptions did we make and do they seem reasonable? Well, we're always making an independence assumption. We're always making some sort of normality assumption when we do these procedures. By independence assumption, I guess if we can assume that the golf clubs are a random sample from the golf clubs, the population of golf clubs we want to test, then we're okay. And by having a random sample, that means the observations are independent and they have the same distribution. Okay, so golf clubs come from a random sample. Golf clubs are a random sample from the population of interest. And our second assumption is that the coefficient of restitution is normally distributed. Okay, so this random sample assumption, that depends how this, we don't know if that's satisfied or not, it depends on the study design. If we knew more about the study design, we could look at look at what they say in the study design and see whether or not you can consider these golf clubs as a random sample from the population of sort of golf clubs produced by this company. All right, how do we check normality?
A normal quantile plot.
That's right, kids, a normal quantile plot. So let's go Q plot of golf. And there it is. Seems to be approximately a straight line. So data are close to a straight line on the normal quantile plot. So seems reasonable. Notice that the assumption here on the golf club example is that the data are approximately normal, whereas the assumption for the sleep example was that the average is approximately normal. So when we use a t distribution for inference, strictly speaking, we're assuming the data is normal, whereas when we use a z distribution, we're relying on the central limit theorem, saying the average is approximately normal. In practice, we only actually need the average to be pretty normal in this case. If you work through the mathematics of the t distribution, the data have to be normal for it to work. But if you do simulations, sort of, if you think about what happens when your assumptions aren't satisfied, when your data is not exactly normal, it's only actually when the average isn't normal that you start to get problems. So strictly speaking, we're saying the data have to be normal, but as long as the average of a sample of this sort of size, so I think we had 15 observations. So as long as the average of 15 observations is going to be approximately normal, then we shouldn't get ourselves into too much trouble with this assumption.